Quickly today, we're going to take a look at kind of a new section. We're going to look at working with coordinate proofs. Specifically, what we're going to do, a few goals for us are to look at placing figures, specifically quadrilaterals, on the coordinate plane, and kind of being able to label their the vertices. That's going to be kind of a complicated part. Then we're going to try to plan and write some geometric proofs, specifically using the coordinates. There's kind of a four-step process for writing coordinate proofs, and this is going to make more sense later. Is we're going to draw and label a graph. Specifically with the shape, whatever they tell us to work on. We're going to state any formulas that we are going to be using. We're going to be showing all of our work. This is really, really necessary when you're proving things. And we're going to have some sort of concluding sentence that states what you've proven and why it's true. So we'll take a look at those today. So we'll start off looking at this. It says questions 1 through 5 determine the coordinates of the remaining points. It's kind of interesting if we start off with a square. It's always a good idea to start placing your geometric figures here at the origin. So one of your coordinates will have the coordinates 0, 0. Now, if we know that coordinates for B are going to be over A and up 0, we know that this length between A and B has to be length A. Well, if this is a square, all four sides are going to be congruent, so we're really going to go up A, we're going to go over A is here. So A is going to be the length of all four of these sides. So if I think about this, I can get the coordinates for D are going to be, again, over 0, but how far up are we? Well, we're up a distance of A. So from the origin, we're over 0 and up A. For C, our coordinates are going to be, well, we're over A and we're up A, so these coordinates are just going to be AA. Does that make any sense? We'll look at a rectangle. Rectangle is very similar. If they give us the coordinates of A, again, we're going to place that at the origin. So it's the coordinates for point A are 0, 0. This means that we're moving, because the first coordinate, the x coordinate of B is A, we know that we're moving over A. We'll notice C is we're over A, but we're up B, so it tells me that this length of the rectangle is going to be B, which means this length over here is B, this length over here is A. So to determine the coordinates for D, that means I'm going to be over 0, but how far up am I? Well, I'm up a length of B. So the coordinates for D are going to be 0, B. If we look at the next shapes, the next shape we're going to take a look at is a parallelogram. A little bit more complicated. Again, we place A here at the origin. We move over a length of A, but we're up 0. If we look at D, D is a little bit more complicated because we're up a distance of C. So this height here is C, and our width kind of in here is going to be B. Well, the thing you need to know about parallelograms is that this triangle that's kind of on the outside is mirrored over here. So this length and this length are kind of a mirror reflection over here. So this length right here is going to be B, and this height here is going to be C. Okay? So what we have is, if we're going to try to find the coordinates of C, we're not only over A, but we're also over a distance of B. So our x coordinate is going to be A plus B. That sounds kind of weird, so let me explain it again. How far over are we from 0, 0? Well, we go over a length of A, that only gets us to here. If we go over a length of B more, that gets us here at C. So our length is A plus B. Our height, well, how far up are we? Well, over here we're up C. Over here we're up C, so we're going to be up C. And A's, B's, and C's are just going to be some sort of values. It could be 1, 2, 3. But we're kind of talking in general, how far over are we? How far up are we? This is weird, is any triangle, okay? Any triangle. Well, if we start over here at the origin and we're at 0, 0, this means we've moved over some length of A over here to get to B. Well, is there any specific relationship between this length of the triangle and the other pieces? We could talk about trig and we could try to figure some things out. Well, we could probably talk about the triangle inequality and kind of figure some things out. But really, when we talk about the coordinates of C, we're going to have to just use two different variables because there's not a direct relationship between the height of a triangle and its base. There's not a direct relationship unless we knew something about the area or anything else. So for this, there's going to be three different coordinates. There's going to be an A, there's going to be a B, and there's going to be a C. For our next shape, we're going to be looking at a rhombus. For the rhombus, the thing you need to know is that each of these lengths is the same. It's kind of an interesting thing. We could probably simplify this a little bit using some square roots and everything. But basically they're saying that A is 0, 0, B, which should really be closer over here. This makes this length A as well. This means that we're going up a distance of C, and we're going over a distance of B. Just like in a parallelogram, this will be kind of mirrored over here. So we're going over a distance of B and up C. So our coordinates for C are we're going over A and a little bit more, so we're going over A plus B. How far up are we going? We're going up C. Well, now that we've established each of the coordinates of these shapes, I think it's kind of important to be able to talk about this in general, okay? So with these coordinates, let me just go back, we're able to actually talk about these shapes in general. So if we're going to talk about squares, we're going to try proving anything about a square, we can actually use these coordinates instead of using a very specific square that might be, length 4 and 4. We can talk about them in general, and this will work whether the square has a length of 4, a length of 20, a length of 300, or a length of some decimal or weird radical. Okay, so these are a good way to talk about shapes in general, and if you can prove something is congruent or something has the same slope or anything like that with generic coordinates, you should be able to talk about the shape then in general and make really big conclusions about it. So here's what we're going to do: is we're going to prove the diagonals of a square are perpendicular. So what we have to think about is we have to think about what does perpendicular mean. Perpendicular means that your slopes are going to be opposite reciprocals. Okay, so this is taking one concept that we've talked about before and really trying to synthesize it with another idea. Then we're talking about the diagonals of a square. So if we had our square, if we remember our coordinates, we said that this was A was 0, oh boy, I can't write anymore. A was 0, 0. We talked about B being over some distance A up 0. We labeled this as D over here. This was over 0 and up A, and this was side C was A. So what we're going to do is when we talk about the diagonals, that means that I'm going to have to show that diagonal AC is going to be perpendicular to side DB. In other words, I need to show that their slopes, or the slope of AC, is going to be the opposite reciprocal when I relate it to the slope of DB. So to write out a specific formula, remember that slope is going to be equal to, or M, I guess, is going to be equal to y2 minus y1 over x2 minus x1. So the first thing I'll do over here is I'll talk about the slope of AC. So the slope of AC, here's C, here's A, that'll be A minus 0 over A minus 0, which will just give me A over A, which should simplify hopefully down to 1. Secondly, I'll talk about the slope of DB. So I'll just put the DB kind of down here. And the slope of DB, I'll use D, and here's B. So I'll say that's going to be, let's see, A minus 0 over, oh, look at that, 0 minus A. Okay, so be careful with the order. When you simplify that, it'd be A over negative A. Well, when I simplify that, that's just negative 1. Well, are 1 and negative 1, are those two opposite reciprocals? Well, yes, they are. So the idea is that I have actually proven, because of these slopes, so I'll have to say some sentence like, because the slopes of my diagonals are opposite reciprocals, then, kind of like an if the slopes of them are going to be opposite reciprocals, then the diagonals are, what am I trying to prove? Well, I'm trying to prove that the diagonals of a square are perpendicular. Okay, so there's what my sentence is. Because the slopes of the diagonals are opposite reciprocals, the diagonals are perpendicular. So that's how I'm proving this. It looks a little sloppy. It's a really good idea to be organized. Kind of start off talking about what is it that you're going to do, sort of build a plan. Well, what does perpendicular mean? Well, it means the slopes are opposite reciprocals. Show your shape. What shape are you going to be working with, just so that everyone's on the same page. Kind of draw your shape. And then have some sort of plan. What is it that you're specifically, according to this shape, going to prove? So these are our diagonals. So this is showing that they're perpendicular. What does that mean? Well, you're going to try finding first off the slope of AC and the slope of DB. What's the formula? List any formulas. And then you're going to show all your work, be very specific. Simplify this down to 1 and -1. You're showing that those two are opposite reciprocals. And then you have to state some final sentence down here to say what you're actually doing. Our next one, it says find the diagonals or prove that the diagonals of a rectangle are congruent. So again, we're looking at diagonals. We're talking about specifically a rectangle. We're trying to prove them congruent. So the diagonals, this means that I'm going to be talking about the distance from, of opposite vertices. Remember, vertices is the plural of the term vertex. I'll draw my picture up here. This is the picture that we had from before, just in case you're curious where I'm getting this from. We put A at the origin. We had B over here was over A up 0. We had D over here was over 0 but up B. And then we had C was one of our coordinates that was up A. I'm sorry, over A up B. So what I'm going to try doing here is I'm going to show that the length AC is going to be equal to the length of BD. What I'm going to need to use is I'm going to need to use the distance formula. The formula for distance formula is just going to be x2 minus x1 squared plus y2 minus y1 squared. So the first thing I'll do is I'll talk about the length AC. I'll be using these coordinates. So I'll start with C, so that'd be A minus 0 quantity squared plus B minus 0 quantity squared. I'll simplify this one step. A minus 0 is A, and then I'll square it. B minus 0 is just B squared. That's as far as I'm going to take this now. I'm going to see how that turns out in relation to BD. I may have to go further, I may not. I'll leave some extra space here at the bottom just in case I need to do that. So I'll look at the length or the distance from B to D. We'll do the same thing. We'll start off, we'll say A minus 0 squared, plus in this case we'd have 0 minus B squared. I'll simplify one step. A minus 0 is just going to be A, so I'll have A squared. Over here I'll have negative B squared. That'll simplify one more step here and just give me A squared plus B squared. At this point, I notice that my distances are congruent, so I'll say because the lengths of the diagonals are equal, try to use a word, the diagonals of a rectangle are congruent. Okay, because the lengths of the diagonals are equal, the diagonals of a rectangle are congruent. It's really trying to state, here's what I found. These two are equal. These two terms here are equal. This one here and this one here are equal. So that means that I'm showing that the distance of the opposite vertices are congruent. In your book, you can see some examples. It'll say something like, place an isosceles right triangle in the coordinate plane, then find the length of the hypotenuse and the coordinates of the midpoint. So what they'll do is, again, they'll set this here at 0, 0, like we've done. They'll put some point, random point P, and they use kind of a letter K, just say that you're over 0 up K. Could it be a K? Could it be an A? Could it be an M? Whatever you really want it to be is fine. You're also over a distance K, so since this is K, it did say it's an isosceles triangle, so that should be the same length. So if this is 0K, this should be K0. If this was M0, you'd say this is M0M. You're then going to talk about finding the, your plan here would be finding the length of the hypotenuse, so you'd have to find the distance between P and Q, and then you have to find the midpoint, which you use the midpoint formula. So if you notice, what they do is they list it, they kind of talk about it, place this in the right triangle, right angle at the origin, let the lengths here be these are the vertices, here's your origin. First you're going to use the distance formula, so here it says PQ is going to equal this, it's substituting values in. Notice it has nice little red numbers for the P and blue numbers for the Q. That's really cute. It simplifies to the best of its ability here. It gets 2 k squared plus k squared is able to say that's 2k squared, and then it simplifies this down to k times the square root of 2. Okay, so that's actually the distance, which is something that we were looking for. Secondly, it says it's going to use the midpoint formula to find the midpoint of the hypotenuse. You're just going to take the coordinates, you're going to add together the x coordinates, divide by 2, add together the y coordinates, divide by 2. We're going to notice our midpoint is something here. We're not really proving anything in this case. We're kind of just showing or finding different coordinates. It's kind of a generic way that if you have an isosceles triangle and you know the length k, you could then kind of find the midpoints of these generically. I don't know how useful it is other than this showing kind of our steps to kind of build some sort of plan, how to draw your diagram, how to talk about your formulas, how to do this in some sort of orderly fashion. It's kind of the use for it. Here's another one that talks about write a coordinate proof for the mid-segment theorem for one mid-segment. We'll talk about mid-segment soon. So it places, again, at the origin, it places someplace over here. Here's a B, which is kind of a complicated thing. It's 2Q or 2R. We'll have to kind of take a look at that. So there's kind of a given and a proof. And we'll take a look at this again when we're talking about the mid-segment theorem. But the solution, we're going to place these here at the certain coordinates. It has to do with the type of triangle we're working on. This seems like a lot of work here. We're really finding the midpoints of things, of D and E. So those are the midpoints. It says prove that this is now parallel to this, so that this line is parallel to this line. In order to prove that, what we're going to have to use is we're going to use some slopes. Because their slopes are the same, because they're both 0, we'll actually do this so we can use a ruler postulate to find the lengths. It's kind of a tough thing really to find what half the length of something is. But this is really proving the mid-segment theorem. And we can talk about more about that when we actually talk about the mid-segment theorem. Your homework is actually to do 2 proofs. It's actually to prove that both pairs of opposite sides of a parallelogram are congruent, and secondly to prove that the diagonals of a rectangle are not perpendicular. So make sure to write these down. Just do them on a separate piece of paper. You're going to be drawing the diagram. You're going to be coming up with some sort of plan. Any formulas you might use, make sure to write them out specifically. At the very end, after you show all your work, make sure you have one complete sentence really talking about what you're doing. For instance, when we talked about the diagonals of a rectangle being congruent, we have some sentence down here. Earlier when we talked about the diagonals of a square being perpendicular, I have some sentence down here really talking about that. If you guys have any questions, make sure to come talk to me. Let me know what your thoughts are on this assignment. Just let me help you.